All right, guys, next we're going to talk about J.J. Thomson, all right? And so I have this nice little picture here of J.J. Thomson. He won the Nobel Prize. And this is a cathode ray tube, or a CRT. Now, CRTs have had a lot of uses, all right? Maybe you've heard of it if you're into electronics. They're the big, deep, fat TVs were CRT TVs or tube TVs. When you think about it, that's where YouTube got its name, because as you watch TV, it's like, oh, you're going to watch the tube because it's cathode ray tube, and then YouTube use that. So anyways, this is a cathode ray tube. You can see there's a description here. What I have right here, though, is a nice little picture of what the heck's going on, all right? And so that blue stream right there, those are electrons that are flowing from the cathode to the anode. And utilizing, it's a Crookes tube is actually what it's called, but utilizing this, what Thomson did is when he put, down here, we're going to say at the bottom, when he put the positive side of a magnet down here, this stream bent towards the positive. When he put the negative side of the magnet on the bottom, this stream bent away from the negative. You guys have played enough with magnets to know about charge. What this told him is that there was a negatively charged thing in the atom or hanging around. So Thomson discovered the electron. Now, you're going to have to get used to this, because when I start talking about electrons, I'm going to do this. Little e with a negative sign, because the charge of an electron is negative. The charge of an electron is negative. You have to remember that. That has to be upstairs. So he's like, oh, great. So Dalton had this idea of spheres. Now we're going to get a better idea of this. He called it the plum pudding model, which makes no sense to anybody because nobody knows what plum pudding is. I'm going to call it the cookie dough model. We've all seen chocolate chip cookie dough. We understand how it functions. The way that he described it, right? And he's like, this is the best I got. And he said, okay, we have our sphere that's the atom. And I said, okay, the electrons are these negative things that are buried within. All right, I'm going to sort of color this in red. In this red, this is positive stuff. He knew the atoms were neutral. So if the electron's negative, then there has to be something counterbalancing that negative charge. And so he wasn't sure what it was, but this was his description. So we now have the cookie dough model. So you can see we started off with just billiard balls. Now we have like pieces. Now we have an electron. We have one piece, which then leads us to this gentleman, Henry Becquerel. Henry Becquerel, this is what I do. I take my kids, I bring them around a fire, and I tell history of chemistry stories. Apparently, he had a piece of radioactive material. It was like the new craze in science, and he put it in his desk drawer with some undeveloped, some photographic paper that wasn't developed, and thinking nothing of it. And when he came back the next day, the photographic paper was developed, and the only thing it had been touching was the rock. So he termed this radioactivity. Radioactivity is the spontaneous emission of radiation. All right, I want you to take a peek at this guy right here. We're going to talk about this picture in class. All right, it's going to be important that we do, because I'm going to walk you through it and you're going to have to make some assumptions about it. Okay, but what you should see here is there's a radiation source here. This plus and minus, those are magnets. All right, that's a magnet, so you have the plus and the minus. This blue line is being pulled up towards the positive. There's a black line that goes straight through, and then a red line that's being pulled slightly down towards the negative. Now we're going to talk about what all of this means, okay?